One of the most exciting possibilities from having this clean, integrated geoscience dataset is the ability to extract features across a wide variety of geoscience data to be used by machine learning algorithms to help the geoscientists describe the core in a faster, more reproducible way. The classification tool provides a very simple interface for the geoscientist to manually label a certain section of core. This might be lithofacies or bioturbation index or some other category of interest. And once a small number of labels are given, a machine learning algorithm can be trained on these features, and that trained model can be used to apply that description to all of the other sections in the entire core. Now, not surprisingly, this isn't going to be correct at first, so it's iterative. So the geoscientists can identify regions where the classification algorithm classified a region incorrectly, and this can be corrected. This allows the classification to get better over time. This produces a more robust core description and vastly reduces the time and manual effort that was required to describe the entire core. The results of this classification are easily exported and can be added back to the main virtual core dataset. Also, the trained classifier can be saved. So if you have wells with a similar set of data, the same description can be applied to them. The interface on the right-hand side provides a simple set of controls to select the machine learning model you'd like to use and adjust the parameters that are being applied. Here we're showing the results from a random forest algorithm, but any number of classifiers can be added to this, including neural networks and so on. Virtual Core's centralized data store and convenient APIs make it easy to develop new machine workflows to identify features of interest. This example shows core photographs and CT scans being used to automatically identify plug locations within the core. This integrated dataset makes it more efficient to develop techniques such as upscaling approaches that can combine measurements from plugs like permeability and porosity and use texture information extracted from core images to develop a procedure to predict these properties throughout the entire core. This is an example of an advanced machine learning algorithm applied to a core photograph. This is an interesting section from the Suevite region of the Chicxulub core. And we have a bunch of different clasts of different types of rock material embedded in a melt matrix. A geoscientist has manually labeled a certain number of these clasts, and a deep learning approach has used this as training data to be able to classify the entire section. And this trained classifier can then be used to look through the entire section, identifying the size and shape distribution of these different clasts. A deep learning algorithm was trained on this data, applying this description to all of the clasts in this entire image. And once this was calibrated, could move throughout the entire 100-meter section, identifying all of the different rock and class types. This provided an excellent comparison with the observations made by a geoscientist.